Hi everyone. Today we're working on solving one-step equations. So title your notes. And in order to solve one-step equations, we need to use inverse operations. Inverse operations are opposite from each other. So addition and subtraction would be opposite from each other, and multiplication and division would be inverse operations. So take a look at the first example. We have x plus 7 equals 10. We have to figure out what number plus 7 equals 10. Obviously it's 3, but you have to be able to show the steps in a one-step equation, because as we get into harder equations like two-step equations and multi-step equations, you have to know the steps to follow. So first of all, we want to look at a one-step equation as two different sides, and those two sides are separated by the equal sign. So on the left-hand side we have x plus 7, and on the right-hand side we have 10. Whatever I do to one side of the equation, I have to do to the other. So my goal is to get the variable by itself. And what number is on the same side as the variable? The 7. How is the 7 attached to the x? That would be with addition. So I need to do the inverse operation, which would be subtraction. So I will subtract 7, and whatever I do on one side, I have to do on the other. I did not add or subtract anything to the x, so I bring that down. Positive 7 minus 7 is 0, so those cancel. Bring down my equal sign. 10 minus 7 is 3, which is what we knew the answer would be, and so x equals 3. Like I said though, easy in this problem, but make sure you get in the habit of checking your work. So what I do is I take the original problem, which was x plus 7 equals 10. But instead of x, I'll plug in what I think the answer is. So 3 plus 7, and I want to see, does that equal 10? 3 plus 7 would be 10. This is 10, and they are equal to each other, so we did it correctly. Take a look at the next example here. X minus 6 equals 11. On the left-hand side we have x minus 6, on the right we have 11. We want to get x by itself. It's got a 6 with it, and it's attached with subtraction. In order to undo the subtraction, I need to add 6, but whatever I do to one side, I have to do to the other. Bring down the x. Negative 6 plus 6 is 0, so those cancel. Bring down my equal sign. 11 plus 6 is 17. So my answer is x equals 17, but I want to check it to make sure. So again, I'll take the original equation, but instead I'll plug in 17 in place of x. And I want to see, does that equal 11? 17 minus 6 is 11. This is 11, and they're equal to each other, so we did it correctly. In the next example, we have 18 equals 3x. So let's look at the two sides of our equation. On the left-hand side, we have an 18. On the right-hand side, we have 3x. I want to get the variable by itself. So now the variable is on the right-hand side of the equation. So that means that I need to move the 3 away from the x. Since this means multiplication, 3 times x, I need to do the inverse operation, which would be to divide. So I'll divide by 3, and whatever I do on one side, I do on the other. So 18 divided by 3 would be 6. I'll bring down the equal sign. 3 divided by 3 would be 1, so this would be 1x, but we already know that 1x is the same as x. So x is now by itself, so my answer is 6. And then we check our answer by plugging it back in. So instead of x, I'll plug in the 6. This is 18. This is 18. They're equal to each other, so it's correct. And then in the final example here, we have x divided by 4 equals 5. So on the left, we have x divided by 4. On the right, we have 5. The variable's on the left-hand side, so I need to move the 4. It's attached to the x with division, so the inverse operation would be multiplication. So I will multiply by 4 on the left, and I'll multiply by 4 on the right. That way, x over 4 times 4 would simplify just to x. I'll bring down the equal sign, and 5 times 4 would be 20. So my answer that I think it is x equals 20, but I'll double check by plugging that in for x and see if that's equal to 5. 20 divided by 4 is 5, this is 5, and so they're equal to each other, so it's correct. That's all for one-step equations. Bye guys.